Hello, good day viewers. In our previous video when we were solving the elective ICT pass question 2021, we were talking about the number bases and the number systems. And I was finding it difficult to make a video on that since the video will be too long. So I've used this time to introduce to you number bases to explain what we were doing. First of all, this video is to introduce the number basis to all of us. It is mathematics, and it also help computer programmers in understanding the relationship between numbers. So here we have 1, 2, 3, 4, 5, and this there are powers among these numbers. The 1, 2, 3, 4, 5 up to 64. There are powers within them. We have powers among some of the numbers here from 1, 2, 3, 4 to 64. The three dots means that it is we ignored some numbers there and now we wrote the last number. Let's start with that powers we are talking about. 1 multiplied by 1 is the same as 1. 1 multiplied by 1 is the same as 1. The one that is underlined will be multiplied with 2. So we multiply that 1 by 2, which is the same as 2. The 2 is underlined. The 2 will be multiplied by this 2 that is encircled. So 2 by 2 is equal to 4. This is a sequence. This is a sequence and it is powers, sequence of powers. And at the end of this show, you understand it. We take the same 2 and multiply it by the 4. We will get 8. We multiply that 8 by the same 2. So you see that we are multiplying everything by 2. 16 by 2. The answer we get by the 2. The answer we get by the 2, which is equal to 32. Okay. So look carefully and pay particular attention to this video. So we can see that some of them have powers because 2 raised to the power 2 is equal to the same 2. Check something out. We have 1 by 1 or 1 times 1, which is equal to 1. And 1 is the same as 1 exponent to 1. And 2 times 1 or 1 times 2 is equal to the same as 2. And 2 is having an exponent of 1. When we take it therefore, 4 is 2 exponent 2. When we take the 8 is 2 exponent 3. When we take the 16 is 2 exponent 4. When we take the 32 will be 2 exponent 5, right? So we're having 1 exponent, 2 exponent 1, 2 exponent 2, 2 exponent 3, up to 2 exponent 5. So we are rearranging the numbers. So 1 exponent 1, 2 exponent 1, 2 exponent 2, 2 exponent 3, 2 exponent 4, 2 exponent 5. We can see that we are having the numbers 1, 2. You see that I'm circling it so that you see it clearly. So 1 to 5, a sequence of numbers. It follows the same order, one after the other. That is it. So we'll explain something here about the number system. First of all, we take these 4 zeros. You see the zeros is equal to 4 zeros. It is the same as 0. So 4 zeros is the same as 0 digits. We will now introduce 1 to 8. So we have 3 zeros and 1. So we have replaced 1 0 with 1. And then here we replace another 0 with 10. So we have 0 0 1 0, which is equal to 2, 0 0 1 1, which is equal to 3. It is a sequence of numbers. We start afresh. We have 0 1 0 0, which is equal to 4. We have 0 1 0 1, which is equal to 5. We have 0 1 1 0, 0 1 1 0, which is equal to 6. These are sequence of numbers. Please start from the 0. We are having 4 digits. All the 4 digits which were 0 is equal to 0. We start from the last right hand, which is equal to 1. We have the 3 zeros and 1 there. So we start from that 1. We have 0 0 1 0, which starts from 2. So it is a sequence of numbers. If you look through carefully, you understand what I'm doing. You understand the video. So it follows the same sequence. 1 0 1 0 is equal to 10. So if you know how to balance your zeros and ones, how to change them, if you look carefully through it, you understand what I'm saying. And that's 1010, which is equal to 10, is the same as A, which is hexadecimal or base 16, and 1011 is equal to 11, which is equal to B. So we replace that last zero on the right hand with 1. And then we start again, 1100, which is equal to 12, or C. Then we have 1101, which is equal to 13, or D. Now we have 1110. We have 1110, which is equal to 14, 10. So the last one will be 1111, which is equal to 15. And that is the base 16. The 16 itself is not included. It is excluded because we started from 0. When we count 0 among the numbers from 0 to 15, it is 16 numbers or 16 values. So the 6 is necessary here for us. The 10 and the 11, which is the A and B, are also necessary for us because it will help us to solve that past question. Not only to solve that past question, but to have a deep understanding about the question and what you are doing to understand the number basis or number system. So 2021 pass go on the conversions of AB 116. Yeah, I think AB 116. Hope you remember that. AB 116 base 16. Yeah, base 16. And we were to convert that to octal, which was base 8. So hexadecimal to octal. So we see how we can go about that, how to do it. Yeah, it is not that difficult, it is easy. From hexadecimal to octal system or base 8 is easy. So that's a 000, 001, 00010. Those are sequences that are there to guide us. It is there to guide us on how to understand number bases, because all the numbers deals with zeros and ones, which is the binary, the basis of that numbers.
Base 8 is 0 to 7. Why? Because 0, when we are counting numbers from 0, so let's count 0. 0 is 1. 1 is 2. 2 is 3. 3 is 4. Like that in that sequence. When we reach 7, it will be 8. The number 7 will be our 8th number, since we counted the 0 among it. So look at how I'm doing it. So the 0 starts from 1 to as we are numbering it. So we count the 0 itself. That is why the 7th number is 8. You see that the 7th number is 8. That is the base 8. So it is 0 to that number. So 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7 is equal to base 8. The 8 itself is not among, or it is not apart. So I think we have a clear understanding of this. So let's move forward. AB 116 hexadecimal. Okay. We have 1 exponent 1, 2 exponent 1, 2 exponent 2. For us to understand, we are bringing back what we did previously. So we take 1 exponent 1. We will take 2 exponent 1, which is equal to 2. We will take 2 exponent 2, which is equal to 4. We will take 2 exponent 3, which is equal to 8. Now we have 1, 2, 4, 8. 1, 2, 4, 8. Now, let's turn it and start from 8 in descending order, not ascending order. So in descending order, we will have 8, 4, 2, 1 instead of 1, 2, 4, 8. Hope you understand. Now, this 8, 2, 8, 4, 2, 1 is a code that will guide us to comprehend or to understand the question. And it will guide us in all aspects to solve the question. So we are aware that our A is equal to 10, 10, which is equal to 10. And our B is equal
to 1011. Yeah, that is our B. So look here. We are turning the next page. That is why we are turning the next page. So the first page to solve the question. I want the camera to be clear. It is blur now, it is blur. So I want it to focus. Yeah. AB116. That was the hexadecimal. Now our A is 1011, B is 1011, our one is 0001, our one is 20011 as we did it here. Now 6 was necessary for us. That is why we brought asterisk, the same as the 10 and the B, the A and the B, which is the 10 and the 11. It is very, very crucial to us. So we brought a sign. So we will do something. We will separate it. So we separate everything. That is separation of values. This is a code. It is a code. Look carefully to understand it. So we take the last one, which is the 0110. We are starting from the back, but we will take only three figures. Only three figures. So the 0 will start from that right hand to 010. That is also three figures. Let's add it. Let's add it. Let's add it. Now it's left with two zeros from that to 1. So we will join that two zeros to that to 1. We join that two zeros to it. Yes, that is separation of values. We are separating the values to get an answer. Left with 20 there. We also join it, that 1 for the B, that one of the B. We join it together. We move again. Not to be confused, we are taking only three values. And I will explain the reason why we are taking only three values. We want to deduce it to the lowest term so that we can work with it, so that it will be super easy for us. So we take 1, 0, 1, 0. So we are starting it again. Not that we are starting everything, but we are starting from where we reach. So we have 1, 2, 4, 1, 2, 4 for all of it. So we will do 1, 2, 4, 1, 2, 4, 1, 2, 4. Or let me say it in another words, 4, 2, 1, which is descending order. Now we bring this 4 to 1 because 1 raised to the power 1 is equal to 1, 2 raised to the power 1 is equal to 2, and 2 raised to the power 2 is equal to 4. And that powers are there to guide us. So the separation of values here, we will add values. You see that I will explain it better. The reason why we are doing this 4, 2, 1 there. So let's continue with what we were doing. 1, 0, 1, 0. We have, it's left with only 2, 0 and 1. 0 and 1. So 0, 1. Let's add another 0 to it. Yes. So that it will be 3. You cannot add 1 to it. You have to just add 0 to it. Yes. Because there's no 1 there. We add 0 to it so that it will be 3 values. Then let's work with it. Here you have 0. So 0 is nothing. So 4 plus 2. The ones which contains the 1 will be added. So when the three values contain 1, those ones will be added and the 0 will be ignored. So 1 and 1 will be added. And it falls on the 4 and the 2. Here the 4 is 0, so it's 0. But the 2 are a map with the 1. So we add it. And the 0 to the 1 is still 0. So we add everything. In the sequence of order, please look carefully. We are having 3 zeros here. For the binary, the zeros and ones, we are having 3 zeros and each maps to 4, 2, 1. That is the sequence of powers. So whenever any sequence of power, which is either 4, 2, or 1, maps to 0, it is the same as 0. So here, all of them were 0. So we add all the 0. And 0 plus 0 plus 0 is the same as 0. Now here, the 4 maps to 0 is the same as 0. But when the 2 maps to 1, it is the same as 2. When 1 maps to 1, it is the same as 1. So 2 plus 1 plus 0 is the same as 3. 4 maps to 1, so we have 4. 2 maps to 0, so we have 0. 1 maps to 1, so we have 1. That is how we go about it. So whenever any number maps to 0, it is 0. When that a sequence of powers maps to 1, it is 1. It is becoming blur. It's becoming blur. Focus. Sorry guys. So here We will add everything. 0 plus 2 plus 0 is 2. 4 plus 0 plus 1 is 5. Yeah, we have 2 and 5. We add 5 here and 2 there. 5 here and 2 there. That is the answer. That is how we solve from hexadecimal to octal. It is not that we are doing just the past question, but we are rather learning on how to convert any number which is hexadecimal to octal. So this is the answer 2530426. So first of all, we will first convert from hexadecimal to binary. We will convert the hexadecimal values to binary. A is equal to 10, which is 1010. B, we will convert to the B2. We will convert everything to zeros and ones, which is the binary. Now, after converting it to binary, we do separation of values. We will separate the values of the binaries to 3 parts. Then we will give 421 to each of them. The 421 is the powers, the sequence of powers, which will guide us to solve everything. So if you follow the procedure, if you follow the method, you can solve it. We've done this 2021 past question. If you find anything, please you can link me in this video. Thank you a lot, guys.